And I have the pleasure to welcome Trey Grainger on stage. I think you probably introduce yourself, and most people know you already. So welcome to Trey.
Thanks, Renee. Thanks, everybody. Now I have to give a proper talk. I don't know what that means, but don't expect much out of that. So not the usual. All right. Okay, so we're going to talk today about personalizing e-commerce search with latent behavioral embeddings. I'll tell you what that means if that's not obvious. I'm the founder of Search Kernel, an AI-powered search consultancy, and previously was the CTO at Presearch, a decentralized web search engine, chief algorithms officer, and head of engineering at LucidWorks. Also worked at CareerBuilder running search. I've been in search for about 2 decades. Wrote Solar in Action 2014 and just published AI-powered search, which I just put a copy over there. If you aren't familiar with it and want to thumb through it, I've also got these little gift, I don't know, whatever these things are, coupon code if you want one. The book is about all things AI-powered search. Definitely recommend checking it out. Happy to chat with you after. What we'll talk about today is largely from the book, code examples in the book, and open source code examples and data sets. So you can take this all and do Docker Compose up on your laptop, pull the data sets, and reproduce everything with Jupyter Notebook. So this is all actual code you can use. But the agenda for today is I'm going to do a quick refresher on embeddings and latent features, talk about the personalization spectrum between search and recommendations. We'll talk about leveraging user signals, user behavioral signals, to implement matrix factorization and personalization from latent features, using embedding vectors to generate personalization profiles, mixing user signals and content-based attributes to generate multimodal personalization, and clustering products by embeddings to create personalization guardrails. And at the end, I'll talk about some of the pitfalls of personalized search and ways you can avoid them. So very quick recap. We all know what embeddings are. You probably all are doing some form of vector search, even if not in your search engine and your Gen AI products at this point. You can chunk documents in different ways, whether it's by word, sentence, paragraph, etc. But ultimately, you generate these lists of numerical features, otherwise known as vectors. Effectively, an embedding, when you see that list of points, is a set of coordinates in a vector space into which we map concepts. And so, very simply, we tend to think of dense vector search, and whether you're using OpenAI or using some other embedding model, you tend to think of vectors as dense vectors with some number of dimensions, 1024, etc. But you can also think of the inverted index for a traditional search engine also as a matrix where each entry in the inverted index has a vector where the number of dimensions for that vector is the number of terms in your inverted index. So for example, if I had, imagine the column, the header up here, that each of these, there's one of these for every term in my inverted index. Then if I had a query for apple juice, for example, that is a vector that has zeros for every single term in the inverted index except for 2. It has a 1 for apple and a 1 for juice, and then a 0 for every other dimension where all the dimensions are all the words in the index. So it's a sparse vector because most of the values aren't filled in, but we can think of sparse vectors, we can think of inverted index as the same general concept. When we go from this high dimensional sparse vector and we start to reduce dimensions, then we get dense vectors. And so this is an example where I've got 8 dimensions now. Instead of every word, I've got concepts mapped in here. One of them, for example, is food. One is drink, dairy, bread, etc. So I look at apple juice, I can see that it's very much not food, very much a drink, no dairy, no bread, no caffeine, very sweet, etc. Same thing for the rest of these. If I look at cheese pizza, very much food, not a drink, a lot of dairy, a lot of bread, very unhealthy. You get the idea. We do this for all these things. So we're mapping these sort of semantic concepts or meaning into these different dimensions. There's 8 in this case. And of course, once we have those mapped in, we do some sort of similarity, cosine, or a normalized dot product is very common. And what that allows us to do is in this vector space where we've mapped each of these items to a set of coordinates, which is the embedding, we can then see that things that are closer together in that vector space are more similar, and things that are further apart are more or far apart. This is hopefully a refresher for many of you. If not, that's the general idea behind vector search. If we move over from thinking about words to thinking about images, I can also look here, for example, and if I search for Darth Vader, I can see that there's this cluster of items that are near Darth Vader that are all together. And if I look for images in this vector space, I see these different images. I could similarly search for something like puppy, and it's all the way, it's kind of hard to see on the screen, but it's all the way on the other side, but all the puppies clustered together. And if you look at different items nearby, you see a bunch of puppies because things that are more similar are closer together. The interesting question, though, if we think about the dynamics of vector space, is what does it mean if we try to find things that are very much like Darth Vader and very much like puppies? Like if we sort of like find the midpoint between the two. And the answer, and this is misleading because this is a two-dimensional visualization of a high-dimensional space, but if you could go to like the average in between them, sort of draw a hyperplane and then find the midpoint, then you would get something like this cute Darth Vader puppy. AI generated, so I don't know, that was fun. But the way this works is leveraging latent dimensions or latent features. What that means is that instead of the example I showed a minute ago, where I explicitly further back than I thought, where I explicitly define these categories and map what's in there with latent features, what we're doing is we are having dimensions that represent lots of different things, the more abstract concepts. And that's really important for being able to do semantic search. So we'll look in a little bit about this notion of latent features, but this talk is about behavioral-based latent embeddings. So just put an asterisk there for now, because we're going to talk more about latent features. In any talk I give, I usually put this diagram up. This is what I call the dimensions of user intent. And the important thing I want to highlight today is that there's three different types of things we have to look at when we're trying to understand users. We have to look at the content that we have in our engine. We have to look at the users themselves. What are their actions? What do we know about them? To sort of understand their intent. And then we have to understand the domain as well. Usually represented as a knowledge graph with whatever the terminology, the connections, the entities, what have you, are in the domain. But if we think about this intersection between the content itself and the text and the user and their behavior and what they're doing, that's where we get into this realm of personalized search. And so that's entirely what we'll be talking about today. And so this is the personalization spectrum as I put it in the book. And I tend to think of search and recommendations as not very different from each other. At the end of the day, you've got, with the search engine, a system that takes in context. It matches based upon that context, and it ranks results based upon that context. The context happens to be usually keywords people are typing in or a question somebody's typing in, some explicit input. With the recommendation engine, you have a system that takes context and matches based upon that context, and then ranks based upon the context. Typically, the context there is more implicit. It's user behavior and what you're able to derive from that. But they're both just an engine that takes context, matches, and ranks, and you could take user behavior as well as explicit input and combine them in any way you want. So they're effectively the same system. It's just a question of which end of the spectrum are you coming from. So in between traditional keyword search and traditional collaborative filtering-based recommendations, we have all these other opportunities in the middle to combine our understanding of the user and their behavior and our understanding of the content. Content-based matching or content filtering is one type of recommendation where you take, literally, here's a document, let me either look at the attributes in it and match them to attributes of other documents, or let me get an embedding of the documents and let me find similar embeddings. This is an easy way to do recommendations purely based on the content. We also have behavior-based matching or collaborative filtering, where we look at users who liked these items also like these other items, and we use the connections that are drawn between items in e-commerce as products in order to understand which products are related. So these are very well understood examples. We can also do hybrid recommendations where we use both the content and the user behavior. But one thing I want to point out is that when collaborative filtering is acting, it is actually just like embeddings operate in a latent space with latent features. Behavioral-based embeddings are sort of internal in what we do with collaborative filtering. So collaborative filtering actually depends on these latent features. So first of all, it's sort of an example I want to talk about how we can generate latent behavioral embeddings for personalization based upon user interactions and behavior. So I'm going to be very quick with code because I know not everyone in here is a developer, but this is just the Spark implementation of a collaborative filtering algorithm called alternating least squares. Just don't worry about the details, but it does something called matrix factorization in order to generate a list of recommendations. So if I run the algorithm, this is what you get out on the other side. What I'm doing here is I'm pre-generating recommendations. I'm then at query time in the search engine, I'm passing, this is Solar, but you could do this with basically any search vendor who's here. I am just passing in a boost query as part of my search. So I'm using the search engine to serve these results, but the ranking is basically being generated externally, and I'm just boosting up the top results. So what you're seeing is pure recommendations served by the search engine, where I've pre-generated the weights of what matters for this particular user. Note this user, just as context, because I'll use this a couple times here. They previously searched for Apple and MacBook, and they previously clicked on an iPad. They added an iPad to cart. They purchased an iPad, and they clicked on a MacBook Air. So you can get a sense of what they're looking for, what brands they like, what types of things they're looking for. So these are just plain, pure collaborative filtering-based recommendations for this user. But if I go and have the user search for tablet, now I'm moving back from the user-based collaborative filtering recommendations approach back to the keyword-based approach. This currently is just a non-personalized query, and it's awful. I search for tablet, and it's just matching the keyword tablet using BM25. However, what if I want to combine the two? So a very naive way to do personalization is let me just take your query, run a search for tablet, and then within those keyword match results ranked by BM25, let me also apply some boosts for the recommendations that I've pre-generated for this user from collaborative filtering. So in this case, note the top of the results are tablets that are similar to this user in terms of what they've interacted before. Notice they're, maybe they're not all Apple, but they're tablets. You've got the iPad at the top. But then notice these are basically filtered recommendations because they're filtered based upon the keyword search from the user. But notice at the bottom, these two items, they're really bad. But the reason they're really bad is because they're the exact same top two items I got from BM25. So basically, once I got through the things I could filter and match from the recommendations list, I'm now showing just normal search results like they would have received before. So this is a naive way to do personalization. We'll see in a little bit why you don't want to do this, but just I'm trying to kind of layer things in as we go. One quick aside, going back to away from user behavior and just thinking about embeddings, like you get from an LLM passing text in and encoding. If these are some items here that I've got at the top, the embeddings that are generated, these latent features, roughly correspond to concepts that matter in terms of ranking. And so in terms of like the meaning of those items. And so you can see this top row here that in general, the higher this value is, it means the item is a larger size. The second one, in general, the higher the value is, this sort of corresponds with color from kind of black to white. This next one has some correlation with like, is this like a computer? Is it an electronic type thing? This last one is somewhat correlated with price, but not independently. Like one row doesn't fully describe any of these characteristics of the products, but sort of in combination across all of these dimensions, you get the representation of height, weight, color, those kinds of things. But this notion of latent features just means that they're sort of hidden features of products that are represented by the embedding that you see. And we know this about embeddings from text and images and things like that, but we don't always think about it this way in terms of behavior. And so one thing I want to highlight is that when we do collaborative filtering, we're also heavily reliant on these latent features. So for example, if we think of the users who like this, also like these other things type approach, let's say I've got a handful of users here who like different movies. So I've got user 1, they like Avengers Endgame, Black Panther, and Black Widow. I've got user 2, they like Black Panther, Black Widow, and Captain Marvel. User 3, Black Widow, The Dark Knight, The Batman. Promise I'll change topics. User 4, The Little Mermaid, The Lion King, and Toy Story. And user 5, The Lion King, Toy Story, and Frozen. So if you're not familiar with any of these movies, here's what the covers look like. But let's pretend like we don't know the titles, we don't know the images, we don't know anything about the stories. And let's just pretend like all we knew was that different users who like some of these movies, user 1, 2, 3, 4, et cetera, that those users are indicating to us that they like these things together. And there's some reason. These are the latent reasons, the latent features or factors. And so if we look at these collectively, like user 1, 2, and 3, what might those latent features be? So for example, all of those movies are movies about superheroes. Most of them were made by Marvel Studios, though some were made by Warner Brothers or DC Comics. They're all action movies, and most of them are not suitable for children due to violence and/or language. If I look at users 4 and 5, all of these are animated movies. They're all suitable for small children, and all of them are made by Disney and Pixar. These are very contrived, simple examples, but the idea here is that these things exist as something that the users care about. They're features of the products and features of the users. It's just that when we do collaborative filtering, we typically just go straight to the recommendations and we don't think about these in-between steps. But when we do, for example, the ALS algorithm, and it uses something called matrix factorization, what we're actually doing is trying to find these latent features, and we're effectively generating behavioral-based embeddings when we do that. So I want to walk you quickly through what that looks like. So when you do collaborative filtering with matrix factorization, you've got your users and you've got your items, and we essentially have a user item matrix here. And then what we're trying to do is decompose this matrix into two matrices. One is a user feature matrix, which has a user mapped to some number of latent dimensions. In this case, for my example, I've got 3, but this could be 1024. It could be whatever number, just a matter of how much compute you have. And then we're trying to also break it into an item feature matrix. So we're trying to say these users and items are paired together. We want to try to figure out what the weight is on the items and what the weight is for the user across some number of latent dimensions. And so as we train this algorithm, sort of going back and forth to try to figure these out, the optimization is that we're trying to make it so that when I multiply these two matrices together, I end up with another matrix that looks just like my original matrix, but it's filled in the whole way. And it should approximate my original matrix. And so at this point, I've got a user down here. If I were to take this user here, this blue one, and multiply it by this item, which is Avengers Endgame, I would get this score as the weight for their recommendations. If I take this user and multiply them by the movie The Notebook, then I get this score. These may or may not be based upon myself and my wife. I'm just saying that, these happen to be some things that people like and maybe don't like. But at the end of the day, what I've done is if you look at these 3 dimensions here, this is a latent feature for user 1, latent feature for user 2, latent feature for user 3, latent feature for item 1, latent feature for item 2, latent feature for item 3. What I've done is I've generated a 3-dimensional matrix based purely on user behavior that is now an embedding that I can use to match and rank just like I would with content-based embeddings. So that's kind of an intro to generating behavioral-based latent embeddings. What we can also do is we can also use text-based embeddings and relate users to items and sort of do some vector math on those items as well to simulate something similar. So switching topics for a second, we'll come back to the latent behavioral-based embeddings shortly. A very naive approach to generating user-based embeddings, which I see is usually everybody's hello world to doing personalization, is to average the embeddings of the past in product interactions. So purchases, add to carts, clicks, et cetera, and then to generate sort of an average of those products, the embeddings from those products to represent the user as sort of a personalization vector for the user. So this works, but I'll show you here why you don't want to do that. So if you look at this example on the left, say I have somebody who is searching for a microwave right now. They've previously searched for or purchased or whatever, a Hello Kitty plush toy, a GE electric razor that's black, a GE bright white light bulb, and a Samsung stainless steel refrigerator. So if I naively just take all their past interactions and average them together and then use that as the personalization vector, when they search for microwave and I'm weighting based upon that vector, I'm going to get this GE black microwave, and I'm going to get this Hello Kitty microwave right here. which they're cute. And yeah, I know the person likes Hello Kitty, but they previously bought a stainless steel Samsung refrigerator. So they're probably not looking for a Hello Kitty microwave. They're probably not looking for a black GE microwave just because that's what the razor they have. You get the idea. So it's really important whenever we do personalization that we not only are able to sort of match their current query, which is what they're searching for, and leverage their past behavior, but that we're able to leverage their relevant past behavior. We need to contextualize it and put guardrails in place so that we can make sure that we're only personalizing when and where it makes sense. And so a better approach to, and then averaging all the past items to generate embeddings for the user, is to find the relevant query context and generate user embeddings dynamically based on that context. So again, not going to go through the code, but this is one easy way to do this is just by clustering products. So I can, for example, take all of the products, take all the embeddings for the products in my index. I can then cluster them together to create n number of clusters, for example, 100. And then whenever I'm running my query, I can take the query, generate an embedding for the query, and then find the clusters that are most similar to my query, and then constrain any embeddings I would personalize based upon to those related clusters. So I'll show you that in a second. So this is just a basic clustering algorithm. If I visualize all of my products, this is again, a two-dimensional projection of the space, but you'll see that this is like CDs and music and guitars. So audio things are kind of towards the top, DVDs, movies, projectors, video things are kind of towards the bottom. Appliances are up here. I've got things like iPods kind of in the middle, batteries, memory. You get the idea. We've put things in a vector space, but now what we can do is we can generate these 100 clusters where there might be, I think we've got 50,000 products in this data set, but I've generated these clusters to represent the sort of locations in vector space where I can classify, leveraging these clusters, the products. So once I've done that, I can now take it, I can stamp on every product what cluster it belongs in. And then when a query comes in, I can try to find the closest cluster or clusters to put it into. So one way of doing that is just to leverage the k-means predicted cluster for that query. Another way is to find the nearest cluster using a code sign similarity or similar. What I tend to prefer doing is doing a KNN. So I use cosine, but I find the top in this case, I'm using 5, the top 5 most related clusters, so that I don't have arbitrary cutoffs in terms of where I'm placing this query. I can find other related clusters, and I can even weight them if I want to. So once I've done that, there's a couple of different approaches for integrating this into a search engine. I can just take a weighted average between the query vector for the embedding for microwave and the vectors for the user's previous interactions. I can perform a standard search and then boost results as part of that search. I can do either of the above, but then only personalize a few items in my result. So for example, if I've got 10 results on my page, maybe I only personalize result 2, 4, and 6, and I leave the others as just plain vector search or embedding or keyword search or hybrid search. So I'm just sprinkling in some personalization as opposed to taking over the whole page, because what if you're wrong? You don't want to completely mess up the results. Or another option is I could use a standard search, keyword or vector or hybrid, but then I can re-rank the results after my initial search based upon the personalization. And the context of what I'm going to show here, I'm doing the last one, mostly just because the re-ranking step is easier to kind of reproduce across all the different search engines with the same syntax. So yeah, we'll just do this one. It's more generalizable, and I'll show you an example. So this code's not super relevant. It's just basic code for generating personalization vectors for the user's query. But what you'll see here is that what I'm doing is I'm generating that list of 5 clusters right here, these query clusters, and then I'm filtering the past interactions that are within those clusters, and then generating a new personalization vector on the fly based upon the relevant past behaviors. So I'm not pre-generating some understanding of the user. This is real time. Every time a user runs a search, purchases a product, adds to cart, the next time they run a search, I'm going to take the relevant past behaviors and generate a personalization vector on the fly based upon their past behavior and based upon the query coming in and what clusters it's in. So this is real-time user profiling basically on relevant context to the query. So I run 2 searches here. One is just like the plain vanilla, no guardrails. I'm not using the clusters at all, which is like the Hello Kitty microwave you saw earlier. And the other is using these guardrails. And these are the outcomes. So on the left, this is a plain vanilla keyword search for microwave, doesn't understand the user at all. In the middle, there's the one I already showed you, which is personalization without these clusters or these guardrails. Then on the right, this is the user's query personalized based upon the relevant context, which is the related clusters, the nearby clusters. And in this case, notice that I'm getting Samsung stainless steel microwaves kind of across the board here. All the other results are still on the list. These are just the ones that are ranked at the top of the list because they're probably the most relevant for this user based upon their actual behavior. So really quickly, a lot of cool stuff there. There's a bunch of pitfalls, as you can imagine, with personalized search. This isn't all just like go roll this out in production now. One is obviously the cold start problem. That applies anytime you're using collaborative filtering or behavior-based recommendations. The nice thing is that back in the day, when we had collaborative filtering and then we just had products with a bunch of attributes, it was semi-hard to do attribute-based matching arbitrarily for users. And collaborative filtering typically takes a lot of data to be able to do it, and you have the cold start problem. With embeddings, for documents, we can now take 1 or 2 interactions and actually generate embeddings that are starting to approximate what the user is looking for. So we can use a lot less interaction data than we used to have to. So basically just combining any behavior-based personalization with some content-based recommendations was really helpful. Guardrails are important, as you saw. If you want, microwaves based upon the razor you use, and if you want Hello Kitty microwaves, then don't do it. But applying guardrails and doing something like the clustering example I showed is really important. Over personalization is also frustrating. So I mentioned I will often just personalize some of the results in the list instead of the whole list, just to make sure the user doesn't feel completely overwhelmed by the personalization that's happening. Feedback loops are important. The user needs to be able to tell you they don't like what they're seeing and to have it fixed immediately, either canceling out the personalization, removing items that the personalization is based upon, et cetera. Privacy is something you have to consider. If somebody's running a search and they start seeing products that are heavily personalized towards weird things that they like and people are walking by looking at their computer, that can be a problem. You should apply personalization with a light touch. Don't go overboard with it. It's very helpful in a lot of cases, particularly, if you're like, a restaurant search engine, if someone searches for hamburger and I'm in Berlin, they shouldn't be recommending me places in Japan and London and the US, because they should understand the context of the domain and the context of where I am. But those are just some things you should watch out for. And then as a last item, multimodal personalization is also possible. So multimodal behavioral personalization specifically. So we talked about generating personalization vectors for users based upon their interactions with items and using the content embeddings of those items and sort of averaging them together intelligently. We also talked about generating behavioral-based embeddings from this matrix factorization that is purely behavioral-based, but you can also combine those together. And so if you start to think of building embedding models and taking, for example, a text encoder that gets you text embeddings, image encoder, image embeddings, you can take these behavioral-based matrix factorization-based embeddings. You can combine them together. You could do another layer of training where you're sort of doing dimensionality reduction and trying to find new things that are connected between the behavior and the content-based embeddings. There's just lots of ways we can interact with this. Most people aren't currently using user behavior in their semantic search systems and their dense vector search systems, just because it's hard. You have to collect the information, you have to process it. It's way easier just to pass text or an image to an LLM. But I'm just noting that this is another query modality we can use. Of course, it's one of many query modalities. So in addition to all these dense vector modalities, there's all sorts of other graph-based, knowledge graph-based, sparse vector-based. There's just a lot of ways to approach search. So these are just a few of the techniques. And this is also even just a subset of the techniques you can use for what I call reflected intelligence, which is taking user behavior and then using that to create models and feedback loops. So there's signals boosting models where you can boost your top products based upon user behavior. There's these collaborative filtering and matrix factorization models. There's the ability to build click models from user behavior to power automated learning to rank. And there's a whole bunch of others that I've got in the book and that I'm happy to talk about offline. But these, this is a small subset of like the domain of search and what you can do with user behavior. But I thought, personalization is something that's a little tricky and a little nuanced, and I wanted to kind of walk through it today. And I think we're pretty close to time. I don't know if there's time for one question, but I'm Trey. This is my book, and I'm happy to chat with you if you've got any e-commerce personalization problems you'd like to discuss. So,
thank you very much. Do we have any questions to Trey? There's one right here.
Thank you for the presentation. Maybe it's a stupid question, but in your examples, are the personalization vectors maintained across multiple sessions, or do you, let's say, restart from scratch every time the user log in or interact with search in a given session?
Yeah, it's a good question. So obviously, depending on what you're building, what scale you're at, you're going to build the system differently. When I can, I prefer to keep that all of that user's history loaded and available during their search session, so that I can, for example, if they run another search, I want to be able to immediately incorporate that into the personalization vector for them. So I do the generation of the personalization vector in real time with each query, but you have to have the sort of previous history available at query time to do that.
Okay, thank you.
Yep.
Any further questions? This one.
In your list of pitfalls, you mentioned feedback loops and privacy. Have you seen any good UIs that help with basically help the user express his discontent?
So I think if you think of just Amazon.com, for example, just for recommendations, you can easily go into your settings and see all the items that you previously interacted with to say, delete this one, take this one away. I think just giving the user the ability to see what data you're using and how you're using it and say, opt out, delete, don't do this, or just turn it off. I don't know. I'm not a UX person, so I don't have like a recommendation on that side, but I think just exposing the data and letting the user see it and interact is what you have to do. Yep.
Thank you for your talk. I really like this idea of the personalized search, but as you said, there's many difficulties, that it's too personalized. What is the one feature that you have found, or have you found one feature where you can say, this is a feature where personalized search really works?
So there's specific domains where you almost have to personalize. I mentioned like the restaurant example. I think in like job search is another great example. If you're a registered nurse in the US, like in Boston, and you search for, registered nurse, for example, ideally things that are closer to Boston would be promoted. Or if you're just a software engineer in Boston and you search for Boston, ideally technical software engineering jobs would show up. You don't have to do that, but it's a wasted opportunity if you don't. So I think there's domains where you almost have to personalize. And then like in the case I was giving, if someone's searching for appliances, typically they want matching appliances. It's very obvious that it would be helpful. So you don't have to do it. You can make them do the work. But as long as you are careful and you only, for example, sprinkle in the items and you don't just take over the whole experience, sometimes you even might show them on the side, almost like recommendations. I just think it's important that the user is helped but not hindered, and you have to just not go overboard. Yeah.
Final question.
Thank you very much for the presentation. I have a question about so the challenge in e-commerce sometimes can be long-term engagement. And then when I think about personalization, it's most of the time relying a lot on user signals. And then by doing a lot of retargeting, actually increasing short-term engagement numbers. But long-term engagement, for what I understand from it, is basically like onboarding users to multiple categories, letting them discover new stuff, like creating prospects, etc. So do you have any recommendations related to that, especially in search funnels, because search starts with needs? So what's your experience on this topic? Thank you.
I think that there's like long-term kind of profiling of the user and understanding them. And then there's like what they're doing now and looking for. Most of what I talked about here is more very short-term focused. I'm not trying to build this big profile. I'm literally trying to understand more per session or per recent activity and per query. These queries are related. They've sort of resumed the same session from 2 days ago. So I'm sort of going back to that. I think the process of generating a longer term understanding of the user is useful and valuable. It's a little outside the scope of this like real-time personalization. And I think you would maybe do that more with the data science team to kind of have that overlay on top. I don't know if that helps, but it's related, but I would probably approach the problem a little differently. Yeah.
Okay, thank you. Thank you, Trey.